Right, good day everyone. Welcome to grade 12 sequence and series mathematics paper 1. Right, therefore now question 2.1. The first term of an arithmetic series it is 7. Alright, the first term it is 7. Therefore now the common difference of this series it is 5. And the series contains 20 terms. 2.1.1, 2.1.1. Calculate the sum of this series. Therefore now remember sum is equal to what? The formula n over 2 and then now 2a n minus 1d. Therefore now the n it is 20 terms, right? It is 20 terms divided by 2 and the first term it is 7, right? Multiplied by 7 plus our n which is 20 minus 1 and the difference which is 5, right? We're given the difference as 5 multiplied by 5. Therefore now if you punch this on your calculator, you're gonna have the sum of 1090. Very good. Right, now let's go to 2.1.2. So then now the original arithmetic series is extended to what? To 75 terms. So then the answer for 2.1.1 it is 1090. Right, so then now it is extended to 75 terms. The sum of these 75 terms it is 14,400. Okay, using sigma notation, write down the equation for the sum of the terms added to the original series. Okay. So then now we can first have Tn, right? Let's go and find Tn because now we have to write using what? Using sigma notation. Therefore now 2.1.2. Therefore now our Tn is equal to our a which is 7 plus n minus 1, n minus 1, n minus 1 and the difference it is 5, right? Therefore now we're gonna end up with Tn is equal to 5n plus 2. Therefore now this is our Tn. Therefore now they said it is extended to 75 terms. Sum of these 75 terms it is 14,400. Write down the equation of the sum of the terms added to the sum. Write down the equation for the sum of terms added, right? For the sum of terms added to the original series. Therefore now we're gonna have the sum of those 75 terms minus the sum of the what? Of the first 20 terms. Remember, it was the series was extended to 75, right? From 20 to 75. Therefore now I'm going to say the sum of 75 terms minus the sum of 20 terms, right? Because we want to find the sum of the terms added to the original series. Therefore now we can have the sum of 75 terms given as 14,400 minus the sum of the first 20 terms which is 1090, which is equal to 13,310. Very good. Therefore now to write it as a sigma notation we can say now 75 and then n is equal to 1. We're starting at 1, right? Our Tn it is this 5n plus 2, right? Therefore now we minused it with the sum of it of 20 terms and we were starting at n is equal to 1. Our Tn is still 5n plus 2, which is equal to what? Which is equal to 13,310. Very good. So then the answer for 2.1.2 it is 13,310. Very good. Let's go to 2. Alright, so then now 2.2, the sequence of the first differences of a quadratic pattern. It is 1, 3 and 5. This is the first difference, right? The first difference. Therefore now if T99, 2.2.1, if T99 of this quadratic pattern it is 9,632, calculate the value of T98, right? Therefore now our Tn will be equal to the difference here. The difference it is 2, right? The difference is 2, and the first term, it is 1. Therefore now our Tn will be equal to 2n minus 1. Therefore now because we have the equation for the first difference, we can say now the 98th term of the first difference is equal to 298. This is T98, right? T98 minus 1 is equal to what? If you punch this on your calculator, you're gonna have 195. Therefore now on quadratic, we're gonna have, because now they said the sum of 99 T99 of this quadratic pattern is 9,632. Therefore now it's gonna have 9,632 minus 195. If you punch this on a calculator, you're gonna have 9,437. Very good. Therefore now we first find the Tn of the first difference. Therefore now you go and find the 98th term of the first difference, which is 195. Good. And then now for the quadratic, therefore now we're gonna minus this term 99 of quadratic, which is 9,632 with 195. Therefore now this is your T98 on quadratic. Very good. Let's go now to question 2.2.2. Right, so then now they're saying if it is further given that the third term of quadratic pattern it is 32. Good. Determine the general term Tn of the quadratic pattern. Okay, so then now we have 1, we have 3, we have 5, and it is further given that we have 32 here, right? Therefore now our first difference is gonna be 1. Wait. Oh, we are making a mistake here. Because now this is the first difference. 1, 3, 5 is the first difference, right? 1, 3, and 5. It is the first difference. Therefore now there's something on top for quadratic. Therefore now we are given that if it is further given that the third term of the quadratic it is 32. Therefore now it means that the third term it is 32. This is where 32 is. This is our 32. Therefore now we're going to have 32 minus this 3, which is going to give us the second term of quadratic, which is 29. We have 29 minus this one, which is going to give us the first term of 28. Therefore now we can continue like that. Therefore now if you want to find a, because now remember for quadratic Tn is equal to an squared plus bn plus c. And therefore now to find a, you say 2a is equal to what? Is equal to the 3 minus 1 is 2, and then 5 minus 3 it is 2. Therefore now 2a is equal to this number, which is 2. Therefore now a is equal to 1, right? Therefore now for you to find b, 3a plus b is equal to 1. We have already yeah, it's equal to 1 because this is where the 1 is coming from. Therefore now our a, we're going to have 3 plus b is equal to 1. Therefore now b is equal to 1 minus 3, which is minus 2. Therefore now to find c, a plus b plus c is equal to this number here, which is equal to 28. Therefore now our a, we have our a, which is 1, and then b, which is minus 2, plus c is equal to 28. Therefore now our c is equal to 29. Therefore now Tn is equal to a, it's not a again, because now we have the value of a is equal to n squared minus 2n plus 28. Good, very good. So then now this is how we find the equation for quadratic pattern, determine the general term Tn, right, for the quadratic pattern. So this is how you find the general term for quadratic pattern. Let's go to the following question. Question 2. Right, so then now for question 2, we're given the geometric series, which is x plus 90 plus 81. Series, here we are talking about serious things, right? We are adding things, serious things, geometric series. Therefore now 2.1. 2.1. Calculate the value of x. You must know that T1 T2 over T1 is equal to what? T2 over T1 is equal to T3 over T2, right? You must know that. Therefore now T2, which is 90, over T1, which is x, is equal to T3, which is 81, over T2, which is 90, right? Therefore now we can cross multiply. Therefore now 81x is equal to 90 multiplied by 90. 9 plus 9 times 9 is 81. Therefore now add 2 zeros, right? Therefore now if we divide by 81, our x is equal to 100. Good. Right, therefore now 2.2. Show that the sum of the first n terms is Sn is equal to 1000 into 1 minus 0.9 to the power n. Okay, so then now the sum for geometric series, you know the formula, Sn is equal to a 1 minus r to the power n over 1 minus r, right? Therefore now our a, it is 100, 1 minus our r, which is 0.9, right? 0.9 to the power n, we don't have n, right? To the power n over 1 minus 0.9. Very good. Therefore now is equal to 100 1 minus 0.9 to the power n over 1 minus 0.9, it is 0.1, right? It is 0.1. Therefore now if you punch this on a calculator, if you punch 100 divided by 0.1, it is going to give you 1000. Therefore 1 minus 0.9 to the power. Good. Very good. Now 2.3. Hence or otherwise, calculate the sum to infinity. You know that the sum to infinity, Sn is equal to a1 minus r. Therefore now a, we have a as 100. Therefore now 1 minus is 0.9, right? R is 0.9, or one can say 9 over 10, right? 9 over 10 and 0.1, it is the same thing, but 0.9, sorry, 0.9, or 9 over 10, right? 0.9 is equal to what? 1000. So this is the sum to infinity. Good. Now let's go to the following question. Question 3. 3. Right, therefore now 3.1, let's say, for which value of x will k is equal to 1 and then now to infinity over there, 4x minus 1 to the power k exists, right? This is interesting. This is interesting. But now let's see, because now here k it is 1, which means now we can say 4x minus 1 to the power 1 plus 4x minus 1 to the power 2 plus 4x minus 1 to the power 3, right? Therefore now we can find r. Therefore now our r is equal to t2 divided by t1, which is what? Which is 4x minus 1 squared divided by 4x minus 1 to the power 1, right? Therefore now our r will be just 4x minus 1. Very good. Even if you use t3 and t2, your r will be 4x minus 1, right? Therefore now we know that if we want to know for which value of x will that exist, right? Therefore now we're gonna have -1, right? R and then less than 1. Therefore now our r, it is 4x minus 1. Negative 1 less than 4x minus 1, it is less than 1. Alright, therefore now we can transpose the minus 1 to both sides. Therefore now it's going to be minus 1 here plus 1, which is 0, less than 4x less than minus 1 plus 1 here, we're going to have 2, right? Therefore now we're going to have, if we divide everything by 4, we divide everything by 4 because we want to know the value of x, right? Therefore now we're going to have 0 x, which is less than 1 over 2. Very good. Therefore now we can exclude 1 over 4. We can exclude 1 over 4, but now this is the correct answer. So this is the value of x by which our will be. Oh, here if we solve for x, right, we're gonna have x is equal to 1 over 4, right? Therefore now we have to exclude, right, because now it will exist only on 0 up until 1 over 2, but we have to exclude 1 over 4. We have to exclude 1 over 4 because now if we solve this, we're going to end up with what? With x is equal to 1 over 4. Therefore now it won't exist on this part. Therefore now we exclude 1 over 4. Now let's go to 3.2. Right, so then now 3.2. Let's say the figure below shows a pattern of 5 circles. A pattern of 5 circles touching externally, whose centers lie on a straight line of length L units. The radii of these circles from a geometric pattern. Okay, it is a geometric pattern. Where the radius of the smallest circle is 3 units, and the fifth, the largest circle, it is 48 units. Therefore now 3.1, determine the common ratio of the geometric pattern formed by the radii of the circles. Therefore now 3.2.1, we have the smallest circle, which means this is T1, right? And the fifth circle, this is T5. Because now it is geometric, we can use Tn is equal to ar to the power n minus 1, right? Therefore now our Tn, let's use T5, right, which is equal to what? To 48. Therefore now 48, which is our Tn, is equal to a. We know our a as 3, right, because now the smallest circle, it is what? It is 3. Therefore now we want r, and therefore now our n, because we use the Tn as 48, our n, it is the fifth, right? It is the fifth, right? The fifth minus 1. Therefore now 48 is equal to 3r to the power of 4. If we divide by 3 both sides, we're going to have 16 is equal to r to the power 4. And then now we're going to end up with our r is equal to 2. Right? We're going to have our r as equal to 2. Right, now let's go to 3. So they're saying determine the value of L. Okay, so like the value from the first, like smallest circle, to the fifth, which is the largest circle, which means in other words they're saying they want the sum, right? The sum, which is equal to a into r to the power n minus 1 divided by what? Divided by r minus 1. And then now our a, it is 3, right? Our a, it is 3, and then r, it is 2, and then our n, it is 5, right? Our n, it is 5. The largest circle here, it is 5 minus 1 divided by r, which is 2 minus 1. Therefore now the value of L is going to be 93. If you punch this on a calculator, you're going to have 93 units. 93 units. 90 93 units. But now here is the catch. Remember they said the radii, right? The radii. This is the radius. The radius is the length from the center of the circle to the circumference. From the center to the circumference. Therefore now we have to multiply this answer by 2 to find L, because now L it is the total distance from this point to this point, right? Therefore now if we multiply 93 by 2, we're gonna have 186 units. Very good. Therefore now 3 point. Right. And then now for 3 point, remember we found R is equal to 2. Therefore now 3.2.3, the pattern is extended by 5 more circles to 10 circles, right? To 10 circles, to 10 circles, to 10 circles. It is extended by 5 more circles to 10 circles. Calculate in terms of pi the total area of 10 circles of new pattern. Remember, the formula to calculate area of a circle, it is pi r squared, right? Therefore now for the first circle we're gonna have pi, the radius it is 3 squared, right? Because now the ratio here it is 2, it means that the following radius for the number, this is the number 1 circle, number 2, number 3, number 4, number 5. Because now our r it is 2, right? Our r it is 2. It means that if we divide the following number by 2, it must give us 3. Therefore now it only tells us that the following term, the second term, the radius it is what? It is 6 squared. Very good. We continue. The following will be, if we divide this number by 2, it's going to give us 6. Therefore now is pi 12 squared up until 10 terms. Therefore now our r will be equal to what? To pi 6 to the powers 2, and then we divide by the term 1, which is 3 squared. Therefore now our r will be equal to 4. Sorry. Right, therefore now to find the sum, we have to find the sum of the area of the 10 circles, right? The pattern is extended to 5 more circles, by 5 more circles to 10 circles. Calculate that in terms of pi, the total area of 10 circles of the new pattern. The total area. So in other words, they mean the sum, like the sum of all areas of all those 10 circles. Therefore now the sum is equal to this is a geometric pattern, right? Therefore now the sum of 10, the sum of those 10 circles is equal to what? Is equal to a, which is 9 pi, right? Because now 3 squared, the first term it is a, right? 3 squared it is 9. Therefore now a it is 9 pi, which is 4, our r over here, 4 to the power n, which is our 10. We minus 1. Therefore now r minus 1, which is gonna be 4 minus 1. Therefore now if you punch this on your calculator, you're gonna end up with 3,145,725 pi. Good. So this is the answer. So it was a very tricky question. Now let's go to the following question. Right, so then now this is our last question. Therefore now question 3.1 are given the geometric sequence, right? The geometric sequence. We are given the geometric sequence of x minus 2 squared to the power 3 to the power 4, and then now x is not equal to 2. Therefore now 3.1.1, determine the value of x where the sequence converges. Therefore now we can find the value of x using r, right? We can say r is equal to the second term divided by the what? By the first term. Remember, this divided by this is equal to this divided by this is equal to this divided by that. Therefore now r is equal to the second term the second term, which is 4x minus 2 to the power 3 divided by the first term, which is 8 x minus 2 squared. Therefore now r will be equal to, okay, if we try to solve this, therefore now we're going to end up with x minus 2, because now 3 minus 2, this 3 minus 2 will be 1. Therefore now we're going to have x minus 2. Therefore now 4 over 8 is 1 over 2, right? Therefore now we can divide this by 2. Therefore we're going to have negative 1 less than x minus 2 over 2, which is less than 1, because now we want to find the value of x where the sequence will converges. Therefore now you multiply everything by 2, x minus 2. Therefore now we transpose this negative 2 to both sides. Therefore now we're going to have 0 less than x less than 4. Good. Right, now 3.1.2. Right, so then now 3.1.2, they're saying determine the sum to infinity if the series it is x is equal to 2, 5. Therefore now a is equal to 8x minus 2 squared. Therefore now we substitute x as 2, 5 minus 2 squared. Therefore now our a is equal to, if you punch this on a calculator, you're gonna have your a as 2. Right, therefore now for you to find the value of r, therefore remember on 3.1.1 we simplified r as equal to it was equal to x minus 2 over what, over 2, right? Therefore now we can substitute our x as 2, 5 minus 2 over 2, and then our r will be equal to 1 over 4. Therefore now the sum to infinity equals to a 1 minus r, and then our a it is 2 over 1 minus 1 over 4, and then our sum infinity it is 8 over 3. Very good. Therefore now 3.2.1. How many terms are there in this series? Remember, for us to find the number of terms in the series, it is n plus, so then our n is going to be what? This 12 minus 3, right? 12 minus 3 plus 1, right? So it is the number on top minus the number on bottom plus 1, right? This is the formula. The number top minus the number bottom plus 1. So then if k was equal to 1, therefore it's going to be 12 minus 1 plus 1, which is going to be 12. But now the k is 3, therefore it's 12 minus 3 plus 1, which is equal to 10 terms. Good. Therefore now 3.2.2. Sorry, it's not 3.3.3. It is 3.2.2. Calculate the sum. Calculate the sum of the series. Right, so then now for us to calculate the sum of the series, we have to find a first, right? Therefore now a will be equal to what? To, let's use the formula that we're given, 3 minus 2, and then we're given k as 3, therefore it's 3 minus 2. If you punch that on your calculator, you're gonna have your a as minus 6. Therefore now to find r, we're gonna have, to find r, let's go and find the second term, which is gonna 3 minus 2, and then k, now we're gonna have k as 4, all right, minus 2. Therefore now if the second term will be minus 12. Therefore now r is equal to minus 12 over minus 6, which is equal to minus 2, right? It is equal to minus 2. No, it's supposed to be 2, right? Oh, I'm sorry about that. I didn't punch this correctly on calculator. Therefore now this has to be 12. Therefore now it is positive 12 over negative 6, which is equal to negative 2, right? Therefore, now let's go and find the sum. The Sn is equal to a 1 minus r to the power n divided by 1 minus r. Therefore, now our a, it is minus 6, 1 minus r, our r is negative 2. Our n, it is 10. Therefore, now divided by 1 minus our r is minus 2, right? Therefore, now if you punch this in your calculator, you're gonna find your Sn as 2046. Very good. This is the end of this session. So then now if you want a full and detailed lessons and sessions based on these and all other topics of life science, physical science, and mathematics, don't hesitate to contact or WhatsApp the number on the description below. Thank you for watching.